Hello guys. Right now we right now in this question it says that computer action from the beam showing treating member AB as a link, which is hinge, and hinge it has an internal load which is Bx and By for shear and Bx for normal force. So calculate the resultant force in the link. So we need the By and Bx of this link. So let's start actually from the right side. We have Cx, Cy, and Cx, and we have the support at A, which is Ay and Ax. Let's disconnect. I will take the right part, side, and it has 9 times 4, which is 9 times 4, which is 36 kilonewton. At C we have upward force Cy and the Cx left, and as we know it is concentrated, so it is 2 feet to the so 3, 4, 6, 7, 8, 9, 10, 11. We have a moment which is clockwise 20 kilofeet, and at B we have force of By and Bx. So let's first find the moment at B, summation moment, in order to find Cy. We actually can find the moment at C. Summary will be By, and from By summation of Fy to find Cy. But let's start from B. So we'll not take Cx since it passed through B, and those two first will not take it. Clockwise 20 gives it plus 36, 11, and we have minus Cy into, sorry, wait, you see 3, 4, 5, 6, 7, 8, so it's 8. And Cy it is 3, 4, 4 plus 3 plus 4, which will give you 10. Solve for Cy. Cy will be equal to 30.8 kilonewton. So it will be 30.8 kilonewton. So let's find summation force of y plus equal to 0 in order to find By, okay? So you have minus 36, since it is down. You have plus 30.8, which is up, plus By, okay, equal to 0. So By is 5.2 kilonewton upward. So our assumption is right. So the other part is we have a link that connects AB to the other side, so it's upward, so it will be downward. By will be 5.2 kilonewton, and Bx to the right will be Bx to the left. And you have here Ay, you have here Ax. So what we're going to do is, can we find the summation of f of x in order to find Bx or Cx? Well, actually, we can't in this part. we need to go to the other beam, sorry, to the other link in order to find bx. So from here we can flip the sign and get cx easily. So our target is to find a reaction, okay? So, so this is summation of moment at A, which is clockwise plus equal to 0, we will get by, where by it's here, okay? It's going by times 3, okay? So by, all of this length is 3, where by is 5.2 times by 3, and bx is minus bx, we're going to find it, and time by 4 equal to 0. So we'll have 5.2 times by 3, which is 4, bx equal to 3.9 kilonewton. Assumption is by 3.9 kilonewton. So bx, the other part, is 3.9 kilonewton. And if you found the summation of f of x right now, f of x plus equal to 0, we will get that uh, minus cx plus 3.9 equal to 0, where cx is equal to 3.9 kilonewton. So, cx is 3.9 kilonewton, and similarly, this one is downwards, so ay will be 5.2 kilonewton by saying summation of f of y upward positive equal to 0. So ay is, let's say, upward, x is up, then by is downward minus by equal to 0, where by we get a 5.2, so ay would be 5.2 kilonewton. Okay, that's it. So you have 5.2. Oh, we forget to find the cx. Actually, cx summation of f of x equal to 0 plus, so minus ax plus, no, sorry, minus 3.9, which is bx equal to 0. So it will form ax equal to negative 3.9 kilonewton, where our assumption of ax is wrong. So 3.9 kilonewton to the right. Actually, you can say, and then erase it. Right, okay. And write 3.9 kilonewton ax, okay. Actually, you can say that bx is 3.9 to the left, then therefore ax is 3.9 to the right, since there is no any intermediate force that interrupts this link. And the other part, we can see this one is part BC, okay, since it is hinged, and we see this is part AB. Okay. So I started with part BC, then I went with part AB in order to find BX, so that I can substitute the BX its opposite direction in order to find CX, and then finding the f of x, summation of f of x, f of y in order to find the support at A. But actually, the question say calculate the resultant force in the lead. So resultant force is goes to resultant force is, where can we say, is our called resultant force. So resultant force, force is square root bx squared plus by squared. We can take this or this, anyone, since we know that the resultant is always positive, the force itself since square. So the dx we get 3.9 square plus by, which is we get a 5.2 square. So our final answer is 6.5 kilonewton resultant force. Okay, and there's another way we could solve this question actually, but this way it's easier. Split then find the by at hinge, by then bx unknowns. Yeah, and for the question we have actually how many unknowns here? We have 1, 2, 3, 4. So we have 4 unknowns. And we only have three equations, which is summation of moment, summation of f of y, summation of f of x. Okay, so actually we couldn't. It is indeterminate. We couldn't solve actually this question in order to find the the reaction and the support. So therefore, they put for you a hinge at B, and the hinge is a connection of a link. Hinge is a connection of a link. So we will add 1, which is a hinge. So the total part is 4 equal to 4, therefore it is determinate. So we can solve it. It is determinate.